Welcome back to Arxflix. Today, we're uncovering an exciting research paper, Spatial Temporal Transformer Networks for Traffic Flow Forecasting. This paper takes on the critical challenge of accurately forecasting traffic flow, particularly for the long term, using a cutting-edge approach. Here's an image illustrating the dynamic components of traffic flow forecasting. Let's explore how the authors aim to revolutionize this task using spatial temporal transformer networks, or ST10s. Traditional short-term forecasting models like time series and Kalman filtering excel in the short term. However, they fall short in the long term due to their inability to capture the nonlinear, dynamic nature of traffic patterns. This becomes vividly clear when the spatial dependencies are highly variable over time. ST10s introduce a novel paradigm by leveraging dynamic spatial and long-range temporal dependencies to improve long-term traffic flow forecasting. This model integrates a new variant of graph neural networks, the spatial transformer, to dynamically model directed spatial dependencies using a self-attention mechanism. The spatial transformer dynamically captures the directed spatial dependencies based on real-time traffic conditions, factoring in connectivity and distance between sensors, and the direction of traffic flows. Various spatial patterns are modeled using multi-head attention, able to identify factors like similarity, connectivity, and covariance. The illustrative architecture of ST10 highlights its stacked spatial temporal blocks, along with a prediction layer, showing the harmonious collaboration between spatial and temporal transformers. ST10s also utilize a temporal transformer to capture long-range bidirectional temporal dependencies over multiple time steps. This is crucial for accurate multi-step predictions, suppressing error propagation, and allowing parallel training to enhance efficiency. This image contrasts short-term and long-term traffic prediction models, illustrating the significance of considering long-range temporal dependencies for long-term forecasting accuracy. The efficiency of ST10s was validated on two real-world datasets, PEMS-BAY and PEMS-7M. The experimental results demonstrated that ST10s consistently outperform traditional models, especially in long-term traffic flow forecasting. Here's a visualization of one-day traffic flow forecasts from ST10, GraphWaveNet, STGSN, and DSTRN models. Notice how ST10 closely follows the actual data flow, especially in regions with abrupt changes, highlighting its superior predictive power. ST10s manage to outperform existing state-of-the-art methods by dynamically modeling spatial temporal dependencies varying with time and road topology. For instance, the PEMS-7M dataset results revealed that ST10 excelled in long-term forecasting compared to its counterparts, a major leap forward in traffic forecasting technology. ST10s propose a significant breakthrough in long-term traffic flow forecasting by dynamically capturing varied spatial dependencies and extended temporal dependencies. This research not only paves the way for more efficient traffic management, but also highlights the potential for dynamic graph neural networks in various applications. That's all for today's video. If you found this insightful, don't forget to like, share, and subscribe to stay updated with the latest research summaries. Comment below with your thoughts and any papers you'd like us to cover next. Until next time, stay curious and keep exploring. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.